Hello everyone, I'm Javier Cifuentes-Faura from the University of Murcia in Spain. It is an honor to participate in this conference as a keynote speaker. Thank you very much to the organization for inviting me. Today we will talk about energy efficiency with the lecture entitled Impact of Technological Innovation on Energy Efficiency in Central and Eastern European countries. This is a work co-authored with different colleagues from China. Energy efficiency and technological innovation are often closely related. A growing number of academic researchers are interested in energy efficiency due to energy and environmental issues. Generally, industrial restructuring and technological progress are associated with energy efficiency enhancements. Energy efficiency improvement through industrial restructuring is currently challenging. Additional cutting-edge technologies are required to address the dual challenges of excessive pollution and power consumption in modern manufacturing. Consequently, adopting innovation-driven development strategies has emerged as a reliable approach to mitigating energy intensity. Technological innovation capability is a crucial metric for assessing the efficacy of an innovation-driven development strategy. This study evaluates the causal nexus between technological innovation and energy efficiency in Central and Eastern European countries, CEE, including the Czech Republic, Hungary, Poland, Romania, Slovenia, Estonia, and Latvia. These countries have witnessed the pursuit of technological innovation to achieve sustainable development, reduce dependency on fossil fuels, and boost energy efficiency. The CEE countries have been characterized by significant energy intensity and reliance on outdated systems. Consequently, this region has emerged as a crucial arena for testing innovative solutions that enable sustained economic growth while minimizing energy efficiency. Including numerous CEE countries in the European Union has accelerated the drive for increased efficiency. Implementing European Union directives and emission reduction targets has compelled the adoption of more sophisticated technologies and energy systems. The Energy Performance of Building Directive, Eco-Design Standards, and Energy Efficient Directive have established robust policy incentives for CEE countries to embrace efficient technologies in buildings, lighting, and vehicles. In addition, technologies are being incorporated into district heating system, electrical transmission, and distribution networks, facilitating intelligent energy management, renewable energy integration, and loss reduction. CE countries have made significant progress through technological advancements and innovation. One key focus has been improving insulation in residential and commercial structures. Adopting energy-efficient heating systems such as heat pumps and biomass boilers has substantially reduced building energy consumption. The widespread use of LED lighting has also resulted in significant energy savings. Installing smart meters and energy management systems in buildings allows for better monitoring and control of energy usage, leading to more efficient operation. The increased utilization of renewable energy sources such as solar, wind, and biomass has improved and reduced dependence on fossil fuels. In addition, implementing energy management systems, process optimization, and waste heat recovery enterprises has enhanced energy efficiency. Efforts to promote public transit electric vehicles and improve vehicle fuel economy have successfully reduced energy consumption in transportation. Technological advancements such as battery storage, smart inverters, and digital grid management have facilitated the increased integration of intermittent renewable energy sources while ensuring optimal efficiency. Several policy measures have successfully promoted technological innovation and improved energy efficiency in CEE countries. One effective measure is the implementation of energy efficiency obligation schemes, which require companies or suppliers to meet specific energy savings targets by implementing energy efficiency measures. For example, in Poland, the National Fund for Environmental Protection and Water Management implemented an obligation scheme that led to significant energy savings in the residential sector. Additionally, for example, Slovakia's Green Investment Scheme provides financial support for energy-saving measures in households, businesses, and public institutions, stimulating the use of technologies. In the case of Romania, for example, has implemented building energy performance standard, improving energy efficiency, and in Hungary, introducing building energy performance certificates and minimum energy efficiency requirements for new construction has encouraged the development and adoption of innovative building materials and technologies. So this study offers several contributions to the existing literature. First, it provides valuable policy inputs for CEE countries by being one of the leading studies on the technological innovation and energy efficiency. It examines how the technological innovation affects the energy efficiency and explores the variation in this relationship. Additionally, it presents new empirical evidence on the causal relationship between technological innovation and energy efficiency, a topic that has not been extensively studied. Thus, it is one of the groundbreaking studies for the CE countries. Second, the study identifies explicit patterns of interaction between technological innovation and energy efficiency and finds that these patterns differ among nations. The study proposes a balanced approach to increase energy efficiency while prioritizing technological innovation. Finally, the study has significant policy implications for improving regional technological innovation and energy efficiency. This study investigates the causal link between technological innovation and energy efficiency by employing panel granular causality analysis, which adds a novel aspect to our understanding of this relationship. Regarding the methodology, this study employs the panel bootstrap granular approach to examine the relationship between technological innovation and energy efficiency in CE countries. This approach offers several advantages. Considering panel heterogeneity, the method investigates the causal relationship between each panel member individually. The approach provides further insights into the characteristics and behaviors of individual group members. Conducting unit root and co-integration testing is unnecessary because of the potential inconclusiveness of their outcomes. The methodology employed in this study enables the identification of the presence or absence of granular causality and directionality, and directional or bidirectional, within a substantial panel of participants. This method considers the presence of cross-sectional dependence and cross-country heterogeneity. It also assists in avoiding contradictory outcomes. Lastly, it can distinguish as many as one panel member's causal patterns. The level variables are determined by the crucial bootstrap values, which operate independently of the unit root and co-integration tests. The methodology used in this study employs the seemingly unrelated regression estimation technique to estimate a system of equations. In addition, wall tests were employed to determine the presence of a causal relationship. The approach also uses country-specific bootstrap critical values, which are valuable because they exclude variables in level 4 and are unaffected by unit root and cointegration characteristics, thus indicating their stationary condition. Identifying causality among nations can be achieved by considering country-specific constraints. The approach to causality using the bootstrap panel method can be expressed as follows. This work employs annual data from 2000 to 2021 to examine the causal association between energy efficiency and technological innovation in CE countries. This period is crucial to CE countries' economic growth and policy processes. The variables are chosen based on their relevance to technological innovation and energy efficiency in CE countries and their availability and reliability in data sources. Energy efficiency is measured by energy intensity, calculated as the total primary energy supply divided by the gross domestic product GDP. Energy intensity, as the amount of energy consumed per unit of GDP, is a fundamental measure of energy efficiency. A decrease in energy intensity indicates that less energy is required to produce the same economic output level, reflecting energy efficiency improvements. This table presents the summary statistics for the CE countries. The mean energy efficiency varies among countries, ranging from approximately 30.47 in Estonia to 49.38 in Latvia. The York-Vera test suggests that the energy efficiency has a normal distribution. However, the technological innovation mean values ranked from approximately 0.49 in Estonia to 19.04 in Hungary. However, Hungary and Slovenia have higher standard deviation, indicating greater variability. Cross-sectional dependence and heterogeneity tests identify the best estimators for panel causality analysis. Four tests are employed to accomplish this goal, and the outcomes are present in this table. The null hypothesis of cross-sectional dependency was rejected at a significance level of 1%, suggesting that the procedure is superior to the country-by-country OLS valuation. This finding highlights the interconnectedness between countries in the CE region, indicating that political or economic instability in one nation can affect neighboring countries. The findings from the homogeneity analysis suggest variation in the causality of disturbance among the CE countries. This table highlights the results for the causal link running from technological innovation to energy efficiency. The null hypothesis that technological innovation does not longer cause energy efficiency is rejected at the 1% significant level in Latvia, Lithuania, and Slovakia. However, the remaining countries of the CE found no impact of technological innovation on the energy efficiency. The findings are highlighted in the table. In Latvia's case, for example, technological innovation has a significant positive effect on energy efficiency, implying that rising innovations lead to improving energy efficiency. New technologies such as more efficient heating system, building insulation, lighting, appliance, industrial processes, and transportation have been adopted in the country, improving the energy efficiency. The transport sector has become more efficient through hybrid and electric vehicles and improved engine technologies in conventional vehicles. The Latvian National Energy Efficiency Plan indicates a notable 15% increase in energy intensity from 2005 and 2016. This finding demonstrates the link between adopting more efficient technologies and saving energy. Similarly, technological innovation has a significant influence on energy efficiency in Lithuania. The commitment to sustainable development has driven technological advancements in the energy sector. According to the result, technological innovation causes energy efficiency in Slovakia positively, suggesting that increasing innovation prompts energy efficiency. The application of smart grid technologies since the early 2000s has allowed for better energy monitoring and management, resulting in increased energy efficiency. More results. For example, energy efficiency significantly affects technological innovation in Estonia, Hungary, and Slovakia. The null hypothesis is rejected at the 1% significant level. In the case of Estonia, the energy efficiency has a significant effect on the technological innovation. The country has implemented strict policies and building codes, which have driven innovation in construction materials, heating systems, and smart controls, thus improving the energy efficiency. Compared with Western European countries, energy efficiency has relatively high electricity and heating costs, and this incentive has increased demand for more efficient appliance, lighting, and industrial processes, which might be why energy efficiency is leading technological innovation. For example, more results. The result reveal that energy efficiency significantly affects technological innovation in Hungary. High energy prices incentive industries and consumers to invest in more technologies, which reduces costs. Hungary has implemented policies and programs of the European Union to increase efficiency across sectors and as an European Union member and improve energy efficiency. We also employ robustness tests in this work. To support the results of this study, we added different tests such as the ordinary least square with a fixed effect. Similarly, the system generalized method of moments SGMM model is included to enhance the validity of our results. The OLS fixed effect model addressed the heterogeneity and cross-sectional dependency phenomenon. Technological innovation has a significant positive effect on energy efficiency, implying that technological advancements has increased the level of energy efficiency. On the other hand, the results reveal that urbanization, population growth, and industry value negatively affect the energy efficiency. However, economic growth and energy and environmental policies positively impact energy efficiency in CEE countries. And now we go with the main conclusions of this study. This study examines the CEE countries to determine the causal nexus between technological innovation and energy efficiency. The results suggest that through various economic and political factors, technological innovation impacts energy efficiency in the Czech Republic, Latvia, Lithuania, Slovakia, and Slovenia. On the other hand, the energy efficiency also significantly affects technological innovation in Estonia, Hungary, and Slovakia. However, the remaining countries have no impact from energy efficiency to technological innovation and vice versa for the CEE countries. The study can offer the following helpful policy recommendations. First, the findings indicate that technological innovation plays a significant role in driving energy efficiency in Czechia, Latvia, Lithuania, Slovakia, and Slovenia. As a result, it is recommended that these nations consider bolstering their innovation policies to enhance economic freedom and growth. Possible measures to promote efficiency gains may encompass subsidies, facilitation of technology startups, and increased investment in science, technology, engineering, and mathematics education. Given the variability relationship between technology efficiency across CE countries, it is imperative to design policies customized to each country's specific condition rather than adopting a uniform approach that may not be suitable for all. The results indicate that energy efficiency significantly impacts technological innovation in Estonia, Hungary, and Slovakia. Therefore, these countries should prioritize implementing reforms that bolster economic freedom and institutional quality to foster innovation. This objective can be achieved by adapting regulation, reinforcing property rights, and promoting market competition. When formulating strategies to enhance technological innovation and energy efficiency, it is imperative to consider the diverse characteristics and variation among CE countries. Finally, countries with no causal relationship necessitate a more comprehensive assessment of the barriers hindering innovation and economic freedom. This effort is crucial prior to formulating policy interventions. In addition, it is essential for the provided links to accurately identify and effectively address distinct obstacles that hinder innovation and efficiency. Governance, financial, and infrastructure policy reforms may be needed. And this is the end of the presentation. Thank you so much for your attention. You can see my mail on the screen, so do not hesitate to contact me if you have any question. Thank you.